Hello my dear students, welcome to chemistry classes. Welcome. In this session we are going to deal with the some questions of JEE mains and JEE mains and KCET questions. Here this is our KCET, NEET and JEE practice series. Here I am solving JEE mains question, and with this, the same question is asked in JEE mains 2015 and KCET 2015. So I am going to solve these two problems in this session. Okay, first let us read the problem. Sodium metal crystallizes in BCC. हमें सोडियम मेटल दिया गया है, क्रिस्टलाइज हो रहा है किसमें? BCC में. BCC lattice with unit cell edge of edge length. So edge length A is equals to कितना है? 4.29 angstrom units. The radius of sodium atom is approximately. हमें क्या कैलकुलेट करना है? रेडियस ऑफ सोडियम एटम. सोडियम एटम का एज लेंथ दिया गया है, सोडियम एटम का नहीं, ये तो बीसीसी यूनिट सेल का. बीसीसी कौन बना रहा है? सोडियम. सो इसको यूज करके हमें सोडियम मेटल का रेडियस को कैलकुलेट करना है. हाउ टू कैलकुलेट दिस? द हिंट फॉर दिस इज दे हैव गिवन बीसीसी यूनिट सेल. First we have to establish a relationship between A and R. A means what? Edge length of the unit cell, and R is radius of the atom. So let us take BCC unit cell. BCC means what? Body centered cubic unit cell. So in body centered cubic unit cell, atoms कहाँ पे रहता है? The atoms or lattice points are present at all the corners. सब कॉर्नर में एक एक पार्टिकल, सब कॉर्नर में पार्टिकल्स रहता है. And also the particles are present at the center of body. One particle is present at the center of the body. So I can draw a body diagonal. Now what I am going to get? What I am going to calculate? I am going to calculate relationship between A and R. So इसका relation calculate करने के लिए हमें इसका length को determine करना चाहिए. Length of body diagonal is equals to. How to calculate this? So let us take, this is our face diagonal. This is our face diagonal. Let us take, this is A, B, C. Here edge length is A, means all the sides, length of all the sides is given as A, and by using this we have to calculate the side of this. So let us take, not this is as C, this as D. Okay. To calculate length of this B, we have to calculate first length of this, and length of this is A. They have given length of this A to D is A because it is the side of the unit cell. So here by using Pythagoras relationship, we can calculate length of body diagonal. If you know the length of A to B and A to D, and how to calculate length of A to B? The length of A to B is calculated by applying Pythagoras relation again here in the given triangle ABC. The triangle ABC. So how to calculate this? In this triangle, let us consider this triangle ABC. The triangle ABC. AB square is equals to AC square plus BC square. Here the length of this face diagonal is equals to AB square is equals to AC square plus BC square. AB square is equals to, AC means what? The length of A to C is a length of the side is A square plus BC. B to C is also A square. So AB square is equals to what? 2A square. The length of AB square is equals to 2A square. Now what we have to calculate? We have to calculate length of body diagonal. So now we have calculated length of face diagonal. And length of body diagonal is calculated by using the triangle ABD. So from the triangle ABD, not ABD, yes, in the triangle ABD. So what we have to calculate is, we have to calculate the length of body diagonal. We have to take the length of, so again we have to apply the Pythagoras relationship. BD square is equals to AD square plus AB square. So what is AD? A to D is the length of our side, So this is A square plus what is AB? AB is our face diagonal. Already we have calculated length of AB square. AB square is equals to 2A square. So therefore BD is equals to root of 2A square plus A square, 3A square. You can write root 3A. So BD is equals to root 3A. And also we know that in BCC the particle is present are at the corner and one particle is present at the body. So the radius of particle is taken as R. From this the length of body diagonal is equals to, in terms of radius of particle, how can you this length? These particles are touching each other along the body diagonal. So the radius is given as, the length of BD is equals to 4R. So here 4R is equals to root 3A. Now we got this, we can equate BD is equals to root 3A, BD is equals to 4R. So we can write 4R is equals to root 3A. And from this we can establish relationship between radius of a particle and side edge length of the unit cell. Now what we have to calculate? We have to calculate R. R is equals to what? R is equals to root 3 divided by 4 into A. So from this directly you can get the answer. So what is the value of root 3? It is around 1.732 divided by 4 into A means what? 4.29. 4.29 angstrom units. So directly what we can do? 1 0 4 7 28. Okay, 1.732 into 1.07. Let's multiply. It's very simple. Now it becomes very simple. 1.07 into 1.732. It's come out to be 1.853 and the unit angstrom around. So the radius is equals to this much, approximately 1.853. So for the accurate calculation we need calci. So we can roughly calculate like this. If the given answer is near with our options, that will be our correct option. Let's check it out. 1.86, first one 1.85, 1.8, 1.8. See here, well the second one is 3.22, 5.7 and 0.93. So our answer is option A, 1.86. Now our calculation gives that 1.85. So this is our answer. 1.86 our answer. Okay. So like this, very simply you can calculate it. So please remember, in case of BCC, this is the relationship between radius and the edge length of the particle. In case of FCC, what it will be? See here, 4R is equals to root 2A. This is in case of FCC. By this you can simplify. By using this you can further simplify this. Okay, we come to the next. So this is most important. Please remember, the correct statement for the molecule cesium iodide is CSI3. Cesium iodide is. They have given 4 options. We have to check it out whether which option is correct according to this structure, the cesium iodide. And generally we know that if a compound is formed like this, AB, if the compound is said to be our ionic compound, what this formula tells? This is our cation, this is our anion. If the compound is A2B, what does this indicate? See here, you can expand this. If I expand this, what I am going to get is the charge of this ion is +1, the charge of this ion is -2, isn't it? So this is our ionic compound. The charge of cation is 1 because on cross multiplying I am going to get this, isn't it? Like this I am going to get the formula. The charge on cation is +1, the charge on anion is -2. If I look this compound according to this CSI3, according to this, if I expand this for this compound, I am going to get wrong answer. See here, according to this, what it will give? CS3 plus I minus. This is wrong. Why? Because this cesium iodide is definitely an ionic compound. Why it is ionic? See here. Do you know cesium belongs to group 1? Cesium is a group 1 compound and the size of cesium is very large. On going from top to bottom, what happens in our periodic table? The size of the atom goes on increasing. As the size of atom goes on increasing, its ionization enthalpy decreases. So due to lowest ionization enthalpy, it can lose one electron very much easily to get its octet. Cesium exists as cesium plus ion. So to get octet, it loses electron very much easily because its ionization enthalpy, ionization potential is very less. And for this triiodide ion, this ion exists as I3 minus. The structure of ion is, see here, this is I and I. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the structure of triiodide ion. This is the actual structure of triiodide ion. See here, in the outermost shell, iodine consists of 7 electrons. It requires 1 electron to complete its octet. But the structure of this is something different. Why? Because see here, iodide exists like this. Here the octet is complete. Here the case is different. Here also octet is complete. Here 2, 4, 6, 8, 10. 10 electrons are here, means this is extended octet. It's a super octet state. Extended octet. The middle iodine ion is present in the super octet state. So we can write the structure like this. The overall charge of the ion is -1. So this charge exists on, according to our formal charge calculation, the charge is found to be, the charge on this is neutral, this is also neutral, and charge on this, the middle iodine atom is -1. So this is the structure of our iodine, isn't it? So this is our CsI3. This is our compound. Cesium is +1 and this I3 ion is -1. So on cross multiplying, what I am going to get? CsI3. So now we can eliminate the so we can get the correct answer. It is a covalent molecule. This is wrong. It is not a covalent molecule because it is an ionic molecule. It is not a covalent. Why? Because this is the largest cation. It is also larger anion. It contains CsI plus and I3 minus. Cs plus and I3 minus. So this might be our answer. It is correct. Let us see the next one. It contains Cs3 plus and I minus ion. This is wrong. So if we calculate, if we go along our according to our formula, we are aimed with Cs3 plus I minus. So but this is wrong. It contains Cs plus I minus and lattice of I2 molecules. This is also wrong. It does not contain any I2 molecules, isn't it? So our correct answer is B. It contains cesium ion and triiodide ion. So like this we can solve. Please remember, this is a particular example of this type. Okay. Thank you so much for watching. Dear students, you are going to you can get this in our description box. You can get the playlist of complete KCET, NEET and JEE series, practice series. Okay. Thank you. Please go and watch. Subscribe to my YouTube channel to get more and more videos. Okay. Thank you.